GTV 好link 咧就係呢度啦，咁大家可以過去 say 個 hi。好，咁我Google Meet 會 mute 咗先。
唔好意思啊，Mr. 梁，想問咧 answer 第8題咧係咪負2啊？第8題啊，test 個
answer。test 嗰個遲啲先講啊，我會 check 嘅，我改嗰時都會 check 嘅，放心。係啦，咁我 mute 咗 Google Meet 先，係啦，即係我之後會 check 翻啦。而家唔特別講 test 住先啦。
哦，咁好啊，唔該，拜拜。
係啦，OK，好。呢個 chat box 好似低咗少少，我一齊洗。OK 好試音啊 ，YouTube 嗰邊試音聽唔聽到 ？YouTube 聽唔聽到聲 ？YouTube 聽唔聽到聲 ？YouTube 聽唔聽到聲？好，應該 OK 啊，應該 OK。好 ，Isaac 仲未見喎，但上一堂應該喺度喎。喂，我見佢上一堂點名係喺度，係咯，上一堂點名喺度，係咪瞓着咗啊？Okay, so we begin. Then let's here we come back to M2 and go on to chapter 7. In fact, the last time I checked our online lesson, it was also chapter 7. And the last time I did online lesson for M2 is chapter 7, and it's about finding maximum and minimum. And in fact, according to the textbook, then this is just the next part after finding maximum and minimum. Therefore, indeed, during that non-online lesson time, then we have not covered a lot. Of course, there is a Easter holiday in between. Therefore, and also apart from that, we also talk about the E and natural log and have a test yesterday. And so that indeed also quite a lot of things. Also, this is about asymptote, and then today we hope we can finish things about asymptote and other property about a graph. And then after we have enough properties, then we can talk about how to draw the graph, how to sketch the graph. That will be our next part. Okay, I just see Isaac is online. I take the roll call first. 好，陳日朗係咪喺度？陳日朗係咪喺度？開 cam。好，喂，遲咗喎，遲咗好多喎，遲咗8分鐘喎嚇。OK， 咁我補翻呢個啦。OK， 我補翻點名啦，不過當遲啦呢個要。Okay, so we back to our textbook part here. So I changed to the display of my iPad and the textbook. Okay, so this is about asymptote, and then we review a little one of the things about asymptote we talked about last time is about the different kinds of asymptote. Okay, so as you can see in the screen here, and then so I just changed it to some notebook writing. So as you can see here, asymptote is a straight line. Oh, sorry, I forget the line. Okay, it's a straight line that a graph gets nearer and nearer to. Okay, maybe I put it in a better way. I don't like adding words like this. Okay, so it is a straight line that a graph gets nearer and nearer to. It is a straight line. The key point is it is a straight line. And usually we don't say it is an asymptote if it is a curve. Okay. Google Meet. OK， 好，唔該晒啊。係 Google Meet 我。 mute Google Meet. Okay, Okay, so it's a straight line that the graph gets nearer and nearer to. Usually we say asymptote, then it is a straight line. If it is a curve, then usually we don't call it an asymptote. And also there are different types of asymptote, as we mentioned before. The type we mentioned is the vertical asymptote. That is when the curve gets nearer and nearer to a vertical line. We can show you some examples first, how vertical asymptote may work. Okay, so for example, I changed to GeoGebra display. So I think this one, yes. Also, GeoGebra is displayed here like that. So I have already typed some equation, but I hide the graph, so I show it here to show you how it is. For example, now I review this one, the green line graph here. Then you can see it is going very high up at this position. If you can see my mouse cursor. While on the other hand, going back down from very low position. Probably the mouse cannot see. Well, anyway, it is about like negative near to -1. Then the graph gets very high and then come back from very low. And then this is a kind of vertical asymptote. If I also draw the straight line, so as we said earlier, asymptote is a straight line. So if I also draw the straight line, x equal to -2/3, and then you can see how this works. So the blue line here shows how it works. Is that so this vertical line then is the asymptote because the green line gets nearer and nearer to it. And also you can see as the green line gets nearer and nearer to this -2/3, then the green line gets nearer and nearer to the vertical line, going higher and higher. While if it gets to the -2/3 from the right hand side, then the green line gets nearer and nearer to the vertical line again, but it is lower and lower. Also, it is a kind of vertical asymptote. How vertical asymptote comes usually is because of the denominator. So refer to the green line equation. The denominator is 3x plus 2. I think the cursor can show here. Where 3x plus 2 is the denominator. And therefore, when the denominator gets 0, then we cannot have denominator 0, right? And therefore, when the denominator gets nearer and nearer to 0, then the function value will get very large or very small. And therefore, that's why it will be getting higher and higher or getting lower and lower. And while I also just got question on why I can immediately know -2/3, it's because I just try to set the denominator to 0. Therefore, I change back to the notebook display. So to find vertical asymptote, we can easily like set the denominator to 0. And by the way, I think just before the online lesson times, I gave you a card showing curve sketching processes. Then you can, for example, like also make notes on that card. Okay, so in case if you want to make it more complete. Also, if we want to know when will be the vertical asymptote, then we can set the denominator equal to 0 and get that x. Therefore, for example, this is the function that I just plotted. Then if we set this 3x plus 2 equal to 0, then it gives us the vertical asymptote. So set 3x plus 2 equal to 0, then vertical asymptote will be x equal to -2/3. And x equal to -2/3 is indeed a vertical line. The vertical asymptote is x equal to -2/3. It is a vertical line. Also, this is an example of a vertical asymptote. And then today, next we are going to talk about other kinds of asymptote. So the vertical one is easy because we just try to set the denominator to 0. Then we can find the x, and then that x will be the vertical asymptote position. Okay, so now what about other kinds of asymptote? As the meaning of asymptote is a straight line that the graph gets nearer and nearer to it. So apart from a vertical asymptote, what other kind of asymptote can it be? then probably it will be like when the graph goes very far away. For example, goes to positive infinity, very far away, or go to the other side, the negative infinity. Because only when we have a going very far away idea, then we can say it goes nearer and nearer. If we are just saying at a specific point, then it is quite difficult for us to say the meaning for nearer and nearer. Right? Therefore, the meaning would be when x goes very far away, like positive infinity or negative infinity, the left hand side. Right? Therefore, okay, the other two, I think we also mentioned the name earlier, but then let's today here our main focus will be try to find it, know how to find it. The others may be the horizontal asymptote, and finally the oblique asymptote. Oh, by the way, the horizontal is written quite poorly, therefore I write it better. The horizontal asymptote and the oblique asymptote. Okay, these two differ by the word horizontal and oblique, and also the meaning are also differ by it. The horizontal asymptote is an asymptote. It's also a straight line, but it is horizontal. While an oblique asymptote is an asymptote, is also a straight line, but then it is oblique. Oblique means it is not vertical and not horizontal. It is not vertical and not horizontal. Therefore, this means not vertical, not horizontal. Neither vertical nor horizontal. And therefore, okay, then I think it will be better for us to see an example. Okay, so it may be better to see example how these kind of other asymptotes work. So I just again use the same example as the one I just showed, but I try to find the not vertical one, And so this one again still the same function, y equal to 4x minus 3 over 3x plus 2. And if I want to know how it would be in very far away, it would be a good idea that we take limits. Therefore, I try to take this limit to x tends to infinity, but still the same function. Therefore, I try to take the limit for the same function, 4x minus 3 over 3x plus 2. Take the limit. Do you remember how do we take this limit? It is a limit at infinity. And I think we have covered it some time ago in chapter 5. And probably if yesterday you study for the test, you may also come across this. Although this one is not our focus in the test of yesterday. But if you study it, you may also have come across it. So how do we do limits like this kind? We always try to make over x, right? We always try to make over x, make something over x. Because if x goes to infinity, then 1 over x will goes to 0. Then we try to make everything here, try to make in the form of 1 over x and make it 0. Alright, so then what we do will be take the limit x tends to infinity and then divide the x for both numerator and denominator. So divide x, and then so do this for both numerator and denominator. Then we have 4 minus 3 over x, and then 3 plus 2 over x. And it is also a general way that we find limits at infinity. So later, if you are asked to find asymptote, probably this may help. Okay, and then next, the over x will all become 0, and therefore we can just replace it. Take the limit now, 4 minus 0 over 3 plus 0, and therefore we have 4 over 3. This is the limit. Alright, that means, what does it mean? That means the graph y equal to 4x minus 3 over 3x plus 2. This graph means also this value. This graph will, the y value will get nearer and nearer to 4 over 3 as x tends to infinity. Okay, it means that this graph, the y value, will get nearer and nearer to 4 over 3 as x tends to infinity. Therefore, the graph should go nearer and nearer to y equal to 4 over 3. Okay, the graph should go nearer and nearer to y equal to 4 over 3. And by the way, y equal to 4 over 3 is a horizontal line. And therefore, if we plot the graph, if we try to sketch the graph, then as x goes to infinity, this graph should go near to y equal to 4 over 3. Okay, let's check. Let's go back to the GeoGebra graph to see these results. See if it matches with our explanation just then. Okay, so still the same graph. Okay, still the same graph, and then I have in fact also plotted the y equal to 4 over 3. Okay, I have already plotted the y equal to 4 over 3, and then which is the g here. Then I try to show it, and then which is the light blue line. Okay, and then you can see how the light blue line is related with the green line. Okay, so you can see here when it is going nearer and nearer, the green line goes nearer and nearer to the blue line, which is y equal to 4 over 3. On the other side, the positive infinity side, it is also the graph comes from down and then go up, and then it also goes nearer and nearer to the blue line. Also, this is an example of horizontal asymptote, and you can see the horizontal asymptote on both sides. The graph also gets nearer and nearer to the same horizontal asymptote, and in fact, it is usually the case. Especially in our M2 syllabus only. In our M2 syllabus, usually the graph will have the same asymptote on both sides. Positive infinity and negative infinity, they are also going nearer and nearer to the same straight line. So this is an example to show you this. Also, I changed back to our notebook. Okay, so this is an example for horizontal asymptote. And then we can put a remark here. This is the horizontal asymptote. Okay, so this is the second case about horizontal asymptote. Then usually, if we want to find horizontal asymptote, we can take a limit to the infinity and see if it is some fixed number. See if it is a fixed number. Therefore, I put some remark here. So take x tends to infinity and see if the y is a constant, a fixed number. And then so finally, about an oblique asymptote thing, we have about 12 minutes left. So we try to talk about also the last kind. Then we can finish the part for asymptote. And then we can, after knowing enough information from a curve, then we can also draw its graphs. 我點知 slope 係0？係其實咧問得非常好，非常好。其實咧嗱，我呢度咧會知道咧，當 x 越嚟越接近，當 x 去到無限，好接近無限，即係越走越遠嘅時候咧，個 y 咧就會係越嚟越接近固定數字嘅，係固定數字嘅。嗱，因為咧，如果好多有啲時候咧，其實你係未必真係會除到㗎啦。呢個咁啱，因為分子分母都係一次方，所以咧你一除嘅時候咧，就大家最大嗰個 power 都變咗數字。所以你就計到個數字出嚟，但係咧，如果你以前做過即係 Chapter 5嗰啲 limits 嘅 exercise 咁，你知道啦，佢未必個次方係一樣㗎。例如上面大啲嘅話咧，咁你呢度咧就會上面嗰個係除唔走嘅，咁就會變咗無限。如果下面大啲嘅話，下面大啲係好啲嘅，下面大啲係0啦，因為下面嗰個大啲你除走嘅時候咧就會變咗上面係0咁樣，咁就會0啦咁樣。咁如果你上面大啲嗰種，佢唔係固定數字咧，咁你就會發覺係唔係一個固定數字嘅。咁所以嗰啲情況就正就係 slope 唔係0嗰種嚟㗎。咁而至於我點知個 slope 咧？咁其實咧到最後咧，即係我完晒呢3 part 之後咧，其實咧我係想大家唔好真係分3類嘅，其實係分2類嘅嚇。其實我係想你分 vertical asymptote 一種，同埋 non-vertical asymptote。不過呢個我想完咗先至再總合。因為咧喺我哋嘅 M2 嘅課程嚟講咧 ，horizontal 定係 oblique 都好咧，我哋可以一齊揾到出嚟嘅，而且佢哋都係一個 x tends to infinity 之下嘅情況嚟嘅。咁所以咧，我哋只要 take 個 x tends to infinity 咧，我哋就可以揾到兩個係會一齊揾到嘅，而且兩個係即係兩個應該係其中一個啦，唔會兩個一齊出現嘅，係 either horizontal or oblique。Okay, so then next we talk about the oblique asymptote. I will try to take a textbook example to show this easier. So textbook example, it is like the textbook example 15, but then I use my textbook extra example 15 to show this. So I take this example to show you the idea for oblique asymptote. Okay, how do we do it easily? Here the function is a little bit complicated. 呢個 y 等於呢個好大嚿啊，好大嚿嘅。And then how do we find the oblique? How do we find its asymptote? Of course, the vertical one can be found from denominator 0. But what about its infinity case? Then we talk about a very important idea. How do we find the asymptotes? Okay, so it is that it is because in our M2 syllabus we only need to know how to find asymptote for rational function. We only need to know how to do it for rational function. Rational function means it is in the form of a polynomial over polynomial. That means in our syllabus, in our M2 syllabus, we only need to know how to find asymptote for polynomial over polynomial. Therefore, if it is a polynomial over polynomial, then we can use what we learned in compulsory part. We can do long division. And therefore, the key idea is to do long division, which means it is the compulsory part chapter 5, the long division. Okay, so let's see what we will get from long division. But this one we will need to expand it first. So by expanding, then we expand the two brackets first, then 2x power 3, and then minus 2x squared, and then minus 3x, and then plus 1 over 2x plus 1 squared. Or maybe the lower part we also need to do long division. We also need to expand. Therefore, 4x squared plus 4x plus 1. Okay, then the long division will be like this. Okay, so I also do a quick long division here. Do long division. 嗱，再講多次啊！我驚頭先大家冇留意到或者聽唔明。我哋喺 M2 嘅範圍內咧，我哋只係需要考慮 polynomial over polynomial， 所以咧我哋一定可以做到 long division 長除嘅。咁當然，如果一個 general function， 例如你有啲 e power 啊，有啲 log 啊，有啲 sine cosine tangent 啦，咁你冇得做長除啦，因為 polynomial 先有長除噶嘛。咁但係咧，你冇我哋喺 M2 範圍內咧，淨係考慮 polynomial over polynomial 嘅啫，所以我哋可以做長除。咁我就 do long division 啦。Okay, so we expand the numerator 4x power 3， 乘開晒佢啦。Then minus 4x square， then minus 6x plus 2， 然後外面嗰個就 4x square plus 4x plus 1。咁呢個都係考驗翻你之前喺 compile 學嘅啫。So we try to make the first one same. Therefore, it is x. So 4x power 3 plus 4x square and then plus x. Then do a subtraction. Subtraction is a negative 4 minus 4. Therefore, negative 8 x square. And then minus negative 6 minus 1. Therefore, negative 7x. And then bring down the plus 2. And then go on, make 4 to negative 8, therefore times negative 2. And so negative 8x squared minus 8x and then minus 2. And then do a subtraction again. Negative 7 minus negative 8, therefore positive 1. And 2 minus negative 2 is positive 4. And therefore, this is the result for long division. And then also in our compulsory part, we know that we can do the division algorithm and we cover the original function. That means the inside can be rewritten by left times up plus down. Okay, this inside can be left times up plus down. But this inside is the same as the numerator. Therefore, we can rewrite this whole thing. Okay, we can rewrite this whole thing. I try to put an arrow here. We write this whole thing to 4x squared plus 4x plus 1 and then times x minus 2 and then plus x plus 4 and over the original denominator, which is 4x squared plus 4x plus 1. Okay, so we can rewrite this original one into this form. Okay, so just rewrite the numerator. We write the numerator using the long division. Okay, then we try to split up these this fraction. Split it up. That means the left one and the right one, separate them. And then so we will have 4x squared plus 4x plus 1 times x minus 2 over 4x squared plus 4x plus 1. Also, the other one, x plus 4 and then 4x squared plus 4x plus 1. Separate them. Separate the two sum here. And by separating, we will always find this term can be cancelled away. Because it is also the meaning for division algorithm. We rewrite it as the quotient x times the divisor. And the lower part, the lower part, the denominator is also quotient. Therefore, they can always cancel out. And therefore, finally, we can rewrite it as x minus 2 and then plus x plus 4 over 4x squared plus 4x plus 1. So finally, we can rewrite the original function into this form. And then making this into this form is good because we want to find the function infinity behavior. So we want to know what it will become when x goes to infinity. But this function is the same as this one. Therefore, this one when x goes to infinity will be the same as this one when x goes to infinity. And what is it like then? What is the last one like then? When x goes to infinity, so as x tends to infinity, then of course x minus 2 it will go to infinity, but I don't want to see this one. I just want to see the other one, the separated right hand side. Then as x goes to infinity, since this has a higher degree in the denominator, this is degree 2, while the upper part has only degree 1, then you can see it always goes to 0. Or if we want to show it more clearly, then we can say this one, if we do a divide x squared, then we will have 1 over x plus 4 over x squared, while it is 4 plus 4 over x plus 1 over x squared. And then this will be 0. This will be 0, this will be 0, and this will be 0. Therefore, it will become 0 over 4, which is 0. And therefore, since it has a lower degree on the upper part, higher degree on the lower part, therefore, it will always goes to 0. And then so, as x tends to infinity, we can know the original function goes nearer and nearer to x minus 2. But x minus 2 is indeed a straight line. Therefore, this function goes nearer and nearer to a straight line. And so, conclusion is the asymptote is y equal to x minus 2. And so this is a general way how we can find oblique asymptote when it is in the M2 syllabus, when it is a polynomial over polynomial. OK， so 嗱總結就係咁啦。咁佢就係一個即係點樣揾 oblique asymptote 咧？就係簡單嚟講咧，就係你做長除就得啦。如果喺 M2 課程以內做長除啦。咁如果你話其他 function 有冇一般方法？有嘅，但係唔喺我哋嘅課程內。咁所以如果第時有機會咧，翻學校之後咧，可能再簡單講一講俾你聽啦。即係如果都想知嘅話，咁但係喺我哋 M2 課程內咧，我哋做長除就可以將個原本嘅 function 縮翻晒一次過全部睇啦，就可以將原本嘅 function 分開咗兩嚿，而分開咗兩嚿出嚟咧，前面嗰嚿如果係 power one 咧，咁後邊嗰嚿咧，後面嗰嚿就一定係分子低次方過分母嘅，所以佢一定會 tends to 0。咁咧所以佢前面嗰嚿如果係 power one 咧，咁個 asymptote 咧就係前面嗰嚿嚟㗎。咁咧呢個就係一個 general 嘅步驟啊。咁嗱呢個咧你第時我唔喺度 show 咁耐，因為我見到差唔多夠鐘，仲有分零鐘啫。咁就如果你第時咧，你可以睇翻睇翻條片啦，然後你可以即係停咗去再慢慢抄翻都得嚇。即係如果你抄唔切，因為我都講得幾快嘅。不過我想翻去筆記嗰度咧寫翻個 remark， 就係我哋點樣揾呢個 oblique asymptote。Okay, so how do we find oblique asymptote? Then we do long division. And then if the quotient is degree 1, then the oblique asymptote is y equal to the quotient. Okay, so this is the remark for oblique asymptote. We do long division. If the quotient is degree 1, then the oblique asymptote is y equal to the quotient. 咁就可以揾 oblique 㗎啦。咁但係如果唔係 係啦，啱啱見到有問題啦。咁如果唔係 Power One 係點咧？咁啊嗱，有幾種情況啦。如果唔係 Power One，仲有幾十秒我講埋佢。咁過翻去頭先textbook 嗰度嗱，如果你都除咗出嚟個 quotient 係 Power One 啊 ，quotient 係 Power One，quotient 係 Power One， 咁呢個就係個 asymptote 啦。咁如果唔係咁點咧？唔係咧就好簡單啦。如果佢呢個係高過 Power One 嘅，即係話 Power Two、Power Three、Power Four 嘅，咁同樣道理個 function 係越嚟越接近嗰個 Power Two、Power Three、Power Four 咯。但係佢唔係直線啊嘛，所以就 no asymptote 啦。喺呢個情況下，如果高啲嘅話就 no asymptote 啦。咁如果你個 quotient 係低過 Power One 咁點啊？咁低過 Power One 得一種情況嘅啫，就係 Power Zero 啦。咁 Power Zero 咧就即係話佢只係一個普通數字，所以如果你個 quotient 係 Power Zero 嘅話咧，咁啊淨得一個數字咧，咁啊即係話嗰個其實係一個 horizontal asymptote 啦。咁呢個咧我就可能留翻聽日我哋再講多少少。咁我聽日先至去做 curve sketching，因為我見到夠鐘啦，我都唔想阻住大家小息。OK， 咁啊總括望多一眼，我哋就翻返去 notebook 嗰邊咧，就係 the three kinds of asymptote vertical we set denominator equal to 0. Horizontal we can take infinity and check if it is constant. Or in fact we can also do long division for horizontal asymptote if it is a degree 0. But while oblique asymptote, we can really just do long division. And then if the quotient is degree 1, the oblique asymptote will be the quotient. Y equal to the quotient. Well, so we will go on tomorrow and see more example probably. Okay, so that's it. Then so we see you again later. In fact, I have prepared a graph, but maybe I show the graph to you next time. Okay, so next time, see you. Goodbye.